My name is Jeff Chilton, and I'm the president of Nammex Organic Mushroom Extracts. And today I want to present a new analytical fingerprinting method for quality control of chaga. Now, the goals for this program are to provide a qualitative and quantitative measurement of primary active compounds in chaga products, and also that these compounds must occur in sufficient quantity to be accurately measured. So we're going to discover scientifically validated and commercially available analytical methodologies. The other thing that we're going to do is discover and identify common adulterants. So what is a medicinal mushroom? Well, according to the U.S. Dietary Supplement and Health Act of 1994, it is a requirement for supplements that the plant part is displayed on the label. The U.S. FDA also has a compliance document that states a mycelium cannot be sold as a mushroom. They are two distinct stages or parts of the Basidiomycete ascomycete organism. So just what fungal parts are being sold as medicinal mushrooms? Well, in China they produce a lot of pure mycelium through liquid fermentation. In the United States, they grow a lot of grain spawn, also called mycelia biomass, and sell that as a medicinal mushroom. Now, there are the mushrooms themselves, which are traditionally used, and in China now they actually collect mushroom spores, Ganoderma spores, and sell them as a medicinal product. There is also the sclerotia form, which some fungi produce, such as Poriococcus. And then, of course, there is chaga, which we're talking about today. So what is a chaga? Well, chaga is neither a mushroom nor an Inonotus fruiting body. And although mushroom and fruiting body are synonymous, the term mushroom often refers to fleshy fungi. Chaga is not mycelia or a sclerotium. Chaga is actually the manifestation of a fungal infection caused by Inonotus obliquus. And Inonotus obliquus is a fungal pathogen commonly infecting birch trees. This type of pathogen is categorized as a canker disease. So, in fact, chaga is a canker. At Nammex, we have identified three primary active compounds that we utilize in our quality control. It's the 1316 beta-D-glucans, ergosterol, ergothioneine, and we also test for alpha-glucans, which is a good way to identify any kind of adulterants. Now, with certain mushrooms like reishi or chaga, we can actually test for triterpenoids, and chaga has 4 of which we are able to test. We use the Megazyme method to test for beta-D-glucans, and we've been using it for about 5 years now. We highly recommend it, and scientists worldwide are using the method now. It's specific to mushrooms. It will also measure alpha-glucan, which are the starches. It's accurate and repeatable. It's peer-reviewed and validated. Easy for company lab use. We've brought it in-house, and we've been using it for about 3 years now. It's also contract lab friendly, so there are many labs now that are offering it, and it's quite affordable. In 2016, the Megazyme method was peer-reviewed by the Journal of AOAC International, and the AOAC is the organization that actually will validate testing methods. We use HPLC for our ergosterol testing. Standards are available. We use it for ergothioneine, and there are also standards available. And then we are using HPLC for the triterpenoids in chaga, and there are also standards available for that as well. So using our analytical testing methods, we have developed a fingerprint for all of the different medicinal mushroom products that we sell. Beta-glucans, alpha-glucans, ergothioneine, and ergosterol. The beauty of using these 4 different compounds is that you can test any kind of unknown product against a standardized profile and then ultimately additional compounds can be added, creating a more robust profile. And in this case, we're going to be adding triterpenoids for chaga. So we've got some really interesting data here for chaga, and this is something that nobody has really done anywhere else. We have 10 samples of raw chaga in this chart from different areas of the Northern Hemisphere. And what we found is there's a very wide variability in triterpenoid presence. And there's also some indication that age is a factor in the quantity of triterpenoids. So in the first two rows, we have chaga from northern China, and the key triterpenoid in chaga is Inonotus, and in this case it is 1.2% or 0.4%, a very wide difference there, and that goes all the way through from Inonotus to betulin, betulinic acid, and trimetanoic acid. We have some chaga from Scandinavia, and we've got three different samples. One is 10 to 15 years old, one is 15 years old, and one is 20 years old. And you can see that those are significantly lower. And you can also see that the Inonotus and all of the other compounds have actually increased, in fact doubled, from 10 years to 20 years. So age does seem to play a part. The samples we have from Eastern Canada are significantly higher in the triterpenoids, a 2.81 to 2.92 in Inonotus from 2 to 5 years, 10 years to 15 years. Now in this case, the amount of triterpenes really has not increased significantly or very little at all during those different growth periods. We have a sample from Western Canada at 6.5, which is extremely high, and this is something where we're going to have to do more testing to find out exactly what's happening there, whether we don't really know at this point in time. And then we have a sample from Alaska, which tested also quite high at 1.8. So the most interesting part of this study is that there is a very, very wide range of triterpenoids in chaga, which is going to have a significant effect on the benefits that one is going to derive from chaga. So doing HPLC testing for chaga triterpenoids is going to be very important for anybody looking at the quality control of their chaga product. So what we've ultimately found and what we've done here, we've got a chaga fingerprint, and that fingerprint starts out with beta-glucans, and chaga actually has very few beta-glucans, very low amount of beta-glucans. In this case, a sort of around 10% beta-glucans, very low alpha, less than 1% alpha-glucan. Ergosterol is low, ergothioneine is low, and I would basically determine that this just indicates the fact that there's a lack of fungal matter in chaga, and I think that's really the case. Chaga is a canker. There is approximately 10% of mycelium, according to one of the only studies that I've seen that has actually looked at chaga in a deep way. I'd also like to point out the fact of we have Inonotus myceliated grain here, and you can see the beta-glucans are 5%. Alpha-glucan is very high due to the grains. And then in terms of the triterpenoids are almost non-existent with the myceliated grain, and that's only to be expected, considering that there's no wood involved in this product. It's just grain, so there's no Inonotus, there's no trimetanoic acid. There's a tiny amount of betulin, and interestingly enough, there's some betulinic acid, and that's something that we'd like to look at further because that seems a little bit out of place. For identification purposes, we prefer DNA analysis. That can get us down to the mushroom species, and it can also identify other organisms as well as yeasts, which sometimes may be put into a medicinal mushroom product. Also, of course, the alpha-glucans. This shows a certificate of analysis for a DNA analysis of Inonotus obliquus, and we have 280 sequences. There are also sequences of other fungi in there, which would be fairly common for a wildcrafted type of product. We were sent a product by a company that wanted us to test their chaga, and we subjected it right away to a beta-glucan test. We found that it had 55% beta-glucan, which was seriously out of whack, so we decided to send it off for DNA because we're really interested in why the beta-glucan was so high, because beta-glucan should have only been 10%. And what we found was that they had, in fact, bumped it up with brewer's yeast. There's a lot of brewer's yeast sequences in there. There were no Inonotus sequences. There were other fungi. There was buckwheat and other plants, so it was a very, very contaminated product. Thank you very much. The Nammex testing methodology is covered in a lot more detail in my white paper published in 2015.